Okay, let's take that study and let's fill in our statistical process specifically for the pieces of the study that go with our process here. So, first of all, the population was the American adults. And then if we look that the data collection was done with random calls to mobile and landlines, and we ended up with a sample of 102 that were interviewed. Summary was done. There was numeric proportions, and graphically there was a pie chart. And that gave us those descriptive statistics. And then the uncertainty was assessed. We had 95% probability that we could take our sample proportions and add and subtract 3.6% to get a confidence interval. And that is the inferential statistic. And that allows us to make that generalization, the headline, many Americans believe fake news is sowing confusion. Okay, now let's look at probability because this is always covered in statistics classes, and hopefully you can see why that's the case now, because we have to have that probability associated with the statistics for it to be inferential statistics, for it to be, something that we can use for a generalization. So definitionally, probability is a measure of uncertainty of an event occurring. And so it gives us the chances or likelihood that a specific outcome or event will happen. And it's a number between 0 and 1, including 0 or 1. Okay, and like we have said, it's important to statistics because it provides a connection between the descriptive statistics, all right, those numbers that describe the sample, to inferential statistics that can be used to describe the population. Okay, so let's look at data types a little bit more here. We know we have the two big types, the quantitative, which are numbers, and the qualitative, which are non-numeric or categories. We can separate quantitative out into two subtypes even further, discrete and continuous. Discrete data, or discrete variables, we get by counting, by asking how many, and those values are going to be from a list of particular values, like 1, 2, 3, 4, 5, 6, 7, right? We can list off the numbers that they can take on. Now, continuous data comes from like measuring something, and it answers a question like how much, and it's any value in a range, okay? Like a height could be any value in a range from, let's say, 4 feet to 7 feet, okay? We can't possibly list off all the possible heights that you could achieve in between 4 feet and 7 feet. So let's just do a little practice here and sort through the types of data in the list there. So number of credits. Okay, so number of credits is going to be quantitative. And so we have to decide, is it discrete or is it continuous? Well, we can count the number of credits, right? It's going to be some number between 3 and 18, but it's going to be specific numbers between 3 and 18, right? 3, 4, 5, 6, 7, etc. Okay, so that would count as a discrete data. Okay, height. I already talked about height. Well, height can be any value in a range of values, so that's, again, it's quantitative and it's quantitative continuous. Favorite color, right. Well, that's not a number at all, so that's going to be a category, so that's qualitative. Now, what about time to take a test? So that's a number. Is it discrete or is it continuous? Well, time is one of those things that really it can take on any value in a range, and there aren't set values that it has to be. So that's going to be continuous. All right, number of sunny days in June. Number of days that we have sun in June. Well, we can count those, so that's a discrete quantitative. Daily high temperature in July. Okay, well it's a number, so it's quantitative. Temperature is one of those things that takes on value within a range of values. Probably in July, we're going to have a low of, maybe something like 70 and a high of something like 95 if we're talking about being in Newberg. Okay, and it can take on any value in that range. There aren't just a certain numbers that it takes on, so that would be continuous. Okay, a little bit more practice here. We want to identify those key terms that we have been talking about for this particular example. A study is done to determine the age, number of times per week, and the duration of residents using a local park in Portland. The first house in the neighborhood around the park is selected randomly, and then the resident of every 8th house in the neighborhood around the park was interviewed. Okay, so we want to identify what the population here is. So the population is residents that are in Portland. Okay, so the houses are the sort of the units that we're going to use to sample, but really we're interested in the residents because it's not the houses that go use the park, it's the residents. The sampling method is systematic, right? We're starting with a certain house and then we're counting off every 8th. All right, one of the variables is duration. What kind of data is that? Well, that's measuring time, so that's quantitative continuous. And what about the color of houses around the park? If we were to select that for a variable, well, that is qualitative. Number of times per week, okay, that's quantitative, and it's something we can count, so that's quantitative discrete. All right, here's another one. I'd suggest pausing and taking a couple of moments to determine what these different things are for this scenario and then listening to the video. Cardiologist is interested in the mean recovery period of her patients who have had heart attacks. She randomly selects 20 of her 100 heart attack patients from the last 5 years. Total, their recovery time is 1,400 days. And we want to identify the following things. So population. Well, population is all the patients that she has had that have had heart attacks. So all of her heart attack patients. The sample and method. So she randomly selects 20. Okay, so our sample is the 20 patients and the method is a random sample. Parameter of interest. Okay, so here is where we cannot give a number here, but we can give in words the parameter that she is wanting to estimate, and it is mean, right? A cardiologist is interested in the mean recovery period. So the parameter of interest is mean. Now the statistic, this is something we can actually calculate a value for. So in words, the statistic is sample mean, and we can calculate it. We can take that 1,400 days total recovery time, divide it by the sample size of 20, and that gives us 70 days. So the sample mean recovery time is 70 days. And we can use that to estimate the population mean recovery time for all of our heart attack patients. Okay, the variable, all right, is recovery time in days, and that data type is quantitative. Okay, that's it for this first lecture.